Chemistry students, this is a video for Wednesday and Thursday, August 26th, 27th. So odd periods on Wednesday, even periods on Thursday, so the same thing. And there, if you click on your link in here, experimental variables and density divers, two things that we are working on. So let's have a little discussion. Here's experimental design. So as you've gone through science classes, they might have taught you the scientific method. You ask a question, you write a hypothesis, you do all that stuff. I'm not concerned about memorizing that. You do that in your everyday life. I mean, you wake up in the morning, okay, it's hot outside. What should I probably wear that's appropriate for hot weather? So you do a lot of that in your head without writing all that stuff down. But in this class, a lot of times, I'll provide a question for you. Why do these two chemicals make a gas when we mix them together? That might be your question. So question or purpose, what you're trying to determine. So in italicized words here, I've just made up an experiment. How does the amount of sunlight affect the growth of pea plants? Okay, so you want to have in your question or purpose what you're measuring and be as specific as possible. You only want one thing you're trying to test. So we're not testing sunlight, we're not testing water, we're not testing fertilizer, we're not testing different types of plants. There's one thing, sunlight on pea plant growth. Your hypothesis, which you guys know, is what do you expect to get out of it? Okay. So, and whenever you write a hypothesis, it's always an if-then statement. So if I increase the amount of sunlight, then pea plants will grow faster or grow taller. Doesn't mean your hypothesis is correct. More sunlight might not make them grow taller. So there's your start to an experiment. Your variables in an experiment. So once you have set up your question and your hypothesis, your variables, your independent variable is the thing you are changing on purpose. In this case, we are changing how much sunlight the pea plants get. So that's our independent variable. The dependent variable depends on that. So what's going to change as a result of changing the amount of sunlight, or what are we measuring? In this case, we're measuring the growth of pea plants. So how does changing the amount of sunlight affect the growth of pea plants? Independent, dependent variable. You only have one independent variable, you have one dependent variable. You don't want to test multiple independent variables at one time. Constant variables, just like the word sounds, things that do not change. So things you're trying to keep the same. So in this experiment, you'd want to keep the types of plants, the temperature, amount of water that they get, the soil, fertilizer. There'd be a whole bunch of things you want to keep the same. So you're only changing sunlight. So you know how the sunlight affects it, not how temperature affects the growth of the plants or how water affects the growth of the plants. Your experimental group is always your group that's actually being tested. So if you have a group of pea plants here, all the ones you're changing the amount of sunlight on. A control group is your normal group. So maybe you have a group over here that you don't change the amount of sunlight. They get the exact same amount all the time. You don't always have a control group. A lot of times when they test medicines, they'll have a group that gets a placebo, like testing for coronavirus, making the vaccine. Some people actually get the vaccine. Some people get a shot that is actually not even real. And they compare that group, the control group that has a shot that's not real, to the group that's actually getting the vaccine. If both of them change the same way, the vaccine's probably not doing anything. Qualitative data. So as the experiment's going, you're collecting some data. Qualitative data would be like the color of the plants. Okay. Quantitative data is always a numerical, a quantity. There's 100 plants. There's 3 hours of sunlight. There's 1 cup of water. So those are just some quick terms. Most important ones would be your independent and dependent variable, which things are constant. So you really need to know independent, dependent variable. Let's do a quick example and I'll be done with this video. I'll try to keep the video short. Sometimes they get a little bit longer. So experiment was done to examine the fuel efficiency of different brands of jet skis. Brands used are Polaris, Sea-Doo, Yamaha, and Kawasaki. All the jet skis are powered by 1100 cc engines. Jet skis were tested in smooth water running at 35 miles per hour for 30 minutes. All right, so first thing, give a qualitative observation you might see during this experiment. So something you might see. The water is smooth. The jet skis are white. Okay. The brands are Polaris, Sea-Doo, Yamaha, Kawasaki. So those are all qualitative observations. Some quantitative observations would be that they are 1100 cc engines. So anything that has a numerical value, 35 miles per hour, 30 minutes. Okay. Independent variable in this experiment. Remember, that is the thing you are changing on purpose. Well, in this case, we're changing the type of jet ski. The thing we are measuring, the dependent variable, is the fuel efficiency of the jet ski. So independent is the type of jet ski. What's dependent on that is the fuel efficiency. And some constant variables. Things that are in here, you want all of them to have the same size engine. They're all running the same speed. They're all in smooth water, all running for the same amount of time. There's probably some other things, like you want to probably make sure that there's the same amount of wind. You probably want to make sure the temperature's the same. You probably want to make sure the same rider, so you don't have somebody really big or really small doing that. So there'll be a lot of constants you want to keep the same in that experiment. One more. Experiments done to determine what materials work best to put out a grease fire on a kitchen stove. 5 different materials are each tested. So I just want to know, what is your independent dependent? So your independent would be your different types of materials, the things you are changing. So you got some flour, some sugar, some water, some ammonium phosphate, whatever else you're using. So that's your independent variable, the things you are changing. And the things dependent on that is how well the fire goes out. So your dependent variable would be how well the fire goes out with each material. All right. That is that. If you go into today, or go to the calendar for that, there is a variables worksheet. I think you'll have to make your own Google Doc. I don't have it set up so you can write right into it, but make your own Google Doc and just, number one, here's my independent variable. You don't have to even label that, or you just say independent, dependent, constant, I, D, and C. That should be fairly quick to do. You can share that with me. The video of this diver will be up, or maybe I will have you try and make that. So this may change. This due date may change on this. I will let you know that soon. Have a good day.